So, right, next slide. Much like OpenAI and DeepMind, we're seeking to build AGI, only we're going to do it first. Just to clarify what I mean by that, AGI is an AI that is sample efficient, meaning it learns from very few examples, like a human would. It is able to figure out what is true, as opposed to just plausible. And it has an internally consistent world model. So this is in contrast to current approaches which have a bit of a truth problem. They're sample inefficient, so they require millions of examples to learn very simple concepts a human would pick up after one or two examples. They see what is plausible rather than true, and they have an inconsistent model of the world. Now, OpenAI, DeepMind, and others like them believe that compression will address these problems. And what that means is that they think that more compressible models are more likely to hold true. But scaling is just going to make the lies more plausible, and compression can't fix that. I have an approach that does. My research shows how to make an AI that is sample efficient, identifies truth, and as a result, learns an internally consistent world model. So this is about more than chatbots, as I said. And for a bit of context, here's my background. I'm currently completing a PhD in computer science. I earlier this year won an award for my research into causal inference and AGI. I have a master's from London Business School, and this is my second time founding a company in the AI space. My previous company, Argon Technologies, was recently valued at 161 million Australian dollars pre-money in its Series B. And its products are used by 25% of global systemically important banks. But most importantly, I have 6 years experience in game design, in studios including EA, Zynga, Creative Assembly, and Rebellion. And this is important because AI is a force multiplier, not a product. I know games and I know AI. I'm going to redefine both. Games rely on engines for standardized parts. These are things like physics, graphics, and developers make content for these engines to run. This is style, narrative, and mechanics. And compelling content is an internally consistent world, which is something we can do. So, why would we build chatbots when we can build worlds? We'll build a game engine for game content, and as a minimum viable product, a tool that decides if content is consistent with a theme. We could use this for things like moderating player behavior, deciding if new content is consistent with a theme. And we'll lay these foundations in 12 months. We'll begin by speaking with developers. I've already got existing relationships in the industry, and game developers tend to make a lot of decisions by word of mouth. They require total control over the technology they use, and their projects are extremely high risk, so they're very careful about working with new people or new tools. So go to develop those relationships out the gate. We hire close to the metal developers to work with these developers. We need these close to the metal developers because what we need to do is build a scalable, highly optimized version of what we already have, which is a simple prototype. Once we get something that is able to be applied to larger scale problems, we're going to demolish some AGI benchmarks and then roll out an MVP to capitalize on the publicity we get from that. So this is how we get to AGI. We get classification of thing. Then we get consistent worlds, and then we get AGI. We do not scale LLMs to get more plausible lies. And importantly, as we're doing this, we validate progress. The better the content we're getting, the closer we're getting to AGI, the more accurately we're modeling real human preferences and desires. And as we get more consistent worlds, we get more reliable AI and robotics, which we can then expand and apply in other domains. For example, in sovereign AI capability, automate industry, make Australia an AI superpower. There are so many applications for this technology if we can make it reliable. So, why would we build chatbots when we can build worlds? Any questions?
Thank you very much. Great presentation. I think when we think about world building, I think we can kind of consider, like most of us have played a lot of games or thought about worlds. What's the most unique world that you can think about using your application?
Oh, I mean, if I could imagine it, it wouldn't be enough, would it? It needs to anticipate what we can't, to get something truly kind of, I mean, I suppose, if I were to compare it what current AI is going to come up with, right? Current AI is going to do what is most mid. This does the opposite. I mean, this is the kind of stuff we can come up with current AI. It's pretty good. We can already do stuff that appeals to human preferences. Just looking at this image is beautiful. But it's also very generic. If you look at the kind of imagery associated with, say, Andreessen Horowitz's Games Fund, it's almost identical to this picture. They come up with the same stuff. Yeah, I guess that is my answer.
Could you provide more detail on who the target customer is?
Yeah, so game developers is the initial customer. So these would be studios like those that I've worked with, Rebellion, Zynga, EA, people I already have relationships with. And the real strength of that is that I can go and ask them what they want from the get-go, so I don't waste months pursuing a customer that doesn't necessarily want what I'm building. Does that answer you?
Yeah, no, that does. And maybe the same on the product. I'm a little bit hazy on, like, when you say worlds, what does that mean more practically?
Sure. So right now we build game engines that simulate physics, lighting, these kinds of things. We don't build game engines that are particularly good at generating visuals from scratch, although NVIDIA is certainly trying. The same is true of sound. You know, there's a lot more we can do there. But where it really gets interesting is when we get into narrative and the actual content of the game. You imagine something like Elden Ring, but generated on the fly. Because when we can generate all these things that are not just visuals and sound, but all the contents, and make it coherent in a way that makes sense across time, then we can generate entire new experiences. And the last thing I can think of that we would really sort of, I suppose the final frontier in this world building would be the mechanics themselves. Because it's not just about like making a new level or something, but like the basic mechanics of the game. If you can generate new basic mechanics on the fly, then you've really done a good job of anticipating human sort of tastes and behavior.
Okay, thank you.
Could I ask, so I'm unclear how, like what the product that you're making is that solves AGI having hallucination problems. You said classification, but can you go into a little more detail about the technical side of that?
Sure. So the working hypothesis of both DeepMind and OpenAI is that they can get around sort of. Are you familiar? Actually, let me think about this. Are you familiar with IXE?
No.
All right. So IXE is a theoretical superintelligence developed by a professor who now works at DeepMind, and it considers different hypotheses that explain what it has seen, different models of the world, and then chooses the one that is most compressible. And by doing so, it's essentially obeying Occam's razor that says simpler explanations are more likely to be true. And what Hutto showed is that this is more likely to identify true explanations of the world. But then his student, Jan Langer, came along a few years later and showed that this was wrong. In an interactive setting, this thesis that compressible hypotheses are more likely to be true doesn't hold up. And that's where I began my research from. I started working, well, if compression doesn't work, then what does? And the metric I came up with I call weakness, or more recently, vagueness. If you maximize this quantity whilst remaining sort of sufficient to explain existing observations, then you maximize the probability that your model will generalize to new tasks or new unforeseen circumstances.
Okay, and does that hypothesis need to be tested?
Well, yeah, it would be interacting with the world. So you definitely have an interactive component, but if you are in the experiments, it was a case of we generate a problem and then see if the hypothesis generalizes. And weakness outperformed compression by 500%. So it was like the first shot was way more likely to be right.
Okay.
Oh, I'm at time. Oh. Thanks very much, everyone.